Welcome, everyone, and thank you for attending part 2 in our webinar series, CBM versus CBO, Improving System Reliability and Grid Resilience with Real-Time Condition Monitoring. My name is Tom Trappell, and I'll be your moderator. And today's webinar will take roughly 45 minutes, followed by 10 to 15 minutes of Q&A. If you happen to miss part 1 of our series, you could find a link to the on-demand recording located in your resource center on the screen right now. Our speakers today are Kevin Walsh, Global Industry Principal for T&D and Smart Grids with OSIsoft, now part of AVEVA, Dan Garvey, Director of Sales and Marketing at PowerRunner, and Jim Thompson, Senior Engineering Solutions Specialist with ComEd. Before we get started, I do want to mention a few housekeeping notes. This webinar is being recorded, and we'll be providing the recording and slides after today's webinar. You can expect an email with all the content we'll be showcasing following the conclusion of our event. And if you have any questions for our speakers today, please feel free to submit them through the Q&A option below on your screen on the On24 digital event platform, and we will answer your questions as they arrive. If we're not able to get to everyone's question today, we will certainly follow up with a response afterward. And with that, I'd like to hand it off first to Kevin Walsh to get started with our presentation today. But gentlemen, thank you all for joining us.
Thanks, Tom. Appreciate it. And hello, everybody. My name is Kevin Walsh, and as Tom mentioned, I'm Industry Principal of Transmission, Distribution, and Smart Grid, and working for AVEVA. Used to be part of OSIsoft, but AVEVA acquired OSIsoft earlier in the year. A couple notes about AVEVA. They are a publicly traded company on the London Stock Exchange, 60% owned by Schneider Electric. We have growing revenues and margins. Total market capitalization is about $13 billion, and in the U.S., the revenue is about $1.6 billion. So we're proud to be part of the growing AVEVA family. If you're familiar with OSIsoft, you know that we specialize and focus on certain critical verticals of industry. I am part of the power and utilities, which is our largest vertical that we sell into, but oil and gas, metals and mining, pharma, chemicals, and manufacturing are other key verticals we deliver the OSIsoft PI system into. Emerging markets such as data centers and facilities, transportation are growing. So again, Tom mentioned this is part 2, and we are in the second of the 2 webinars. But the first webinar, we discussed what I call the traditional grid assets. And today, part 2, we will discuss the next generation of assets which reside on the distribution grid, the low voltage network. Although the next gen assets like secondary transformers, line sensors, and smart meters may not be as expensive as the critical assets that we talked about in part 1, but the dependency on them and their data is growing with every passing year given the direction of the policies and the requirements of the distribution network. So here you see some of the traditional assets that we went in depth on. Yes, they're key in the performance of the network, but they all have different characteristics from what we're going to be talking about today. Today, we're more focused on the low voltage network. And the characteristics that I mentioned that kind of change are the data and the volume of data. And also we're moving from a static environment to a dynamic environment. And what do I mean by that? The distribution grid is always changing the network topology versus what happens in the transmission side or the medium voltage side. The data that we get from the smart meters is very valuable to use against the health index of the low voltage equipment. Low voltage equipment usually was, run to failure, but now we have this unbelievable amount of data coming from the grid that we can now leverage it with the right technology to start looking at them like we did the critical assets or the traditional assets and looking at their health and making sure they're in operations because the direction of the network is changing drastically. So I kind of brought this quote up last time, but I still think it hits home, right? Basically, T&D World from Paul Malden in 2015 stated this. The gentleman had some foresight. In the past, we've always tried to fix reliability issues in the transmission system where we had more control and we were willing to make the bigger financial and technology investment. The distribution system was more of a neglected stepchild. But now distribution and customer systems with growing DG, microgrids, storage, automation, smart grid is becoming the center of the technical, financial, regulatory attention. Some folks are suggesting that we'll soon have DSOs, distribution system operators. This was said in 2015, and it's true. And why is it true? Another famous picture I like to use, this came out of over 5 years ago from EPRI. It's showing the conversion of technology, the data, and the transition of consumers to prosumers on the distribution grid. If I was to change one little thing on this picture, it would be the arrow being bidirectional from the prosumer, because they are producing energy or storing energy at their residential level. And because of what I mentioned earlier, about the dynamic nature of the network, the growing data volume, we've reached out and started a critical partnership with PowerRunner. So what we're doing is all about data governance and situational awareness. I know you're going to have your control systems, DERMS, ADMS, but there's still a lot of value that you can get from that data underneath these major systems. And it's about situational awareness. Situational awareness will hit departments for engineering, support engineering, maintenance, assets, and also will help understand your capital and O&M spend when you get better insight into this data. So between the two systems of Pi and PowerRunner, we're introducing into the market a very valuable solution to help the distribution system operators, the distribution companies, muddle their way through this. With the FERC 2222, which is now being introduced into the market, situational awareness and getting an understanding of this data is more critical today than it ever has been. As you kind of walk through the history of the unbundling of the utility, basically from generation to transmission, and now into the distribution with the unregulated power systems and energy, it's now about making the distribution network intelligent. And to be able to do that, you really need a system that balances OT and IT. This is not a IT challenge. It's actually an OT challenge. And the subject matter experts reside on the OT side. So we are putting together a solution that IT can support, but it's really aimed at the business user and the business. And to tackle what I kind of gone through about the scale, the dynamic nature, and the volume of data coming at you. So we're looking at and hitting the check marks of performance and scalability, data governance and data management, all critical to be able to rely on that data and trust that data. And then the contextualization. We need to put contextual information around the raw data to bring life to it and more meaning. And then again, as I mentioned, the subject matter experts in the OT side, a business user configurable. We believe in the power of the user and the subject matter expert that resides on the business side to be able to handle what's coming at them. And with that, I'd like to hand it over to Dan Garvey from PowerRunner to take it from here. Dan?
Hi, thank you, Kevin. And good morning. Thank you all for your time. So just to give you a little background on PowerRunner. So first of all, we were formed in 2007. We initially began as a consulting company, standing up a lot of the central markets, or at least working in the participation to stand up the central markets. And since then, probably about 2010, we pivoted towards a software company and have over 20 in production use cases today. So a little bit more too about our technology. The technology in and of itself is, a configurable platform. It's a data virtualization layer that joins all of these disparate data sources that that utilities need to ingest in today's environment. We've got some embedded AI and ML for predictive analytics and other solutions. And again, we're going to hit on this theme throughout the entire presentation here, is that it's user configurable. So the business user front end is really where the value is in this. So let me just sort of talk a little bit about the solutions themselves. It is a platform joined together with Pi. It's a very powerful data operations platform. So we deliver pointed solutions. Jim Thompson today will go through one of those solutions that we stood up. And it's a relatively quick deployment, rapid deployment, which brings immediate value to our customers. So picking up a little bit on what Kevin just mentioned, if you think about the changes that are going on across the grid today, asset management, CBM, CBO, it's got to drop down to the next level. Obviously, in the first presentation, you saw a focus on more of the capacity, more of the transformer and substation type of assets, the larger system assets. But now we've got to look at what is the impact that these new DER assets are having on the system. The large community solars and microgrids, they're relatively, let me rephrase that, they can be monitored because they are large assets that have interconnections. But the problem really comes with the spread of distribution assets behind the meter. We jokingly refer to it as, the death of a million cuts. All of these assets are having an impact across the distribution system. For instance, take this one pole top transformer here in the center where you've got two EVs that have now, put in charge packs in their garages. You could easily be overloading a transformer here. So this is visibility that we need to now incorporate into more of a CBO type of process. After all, CBM, CBO, asset health, it's all about improving SAIDI and CAIDI. And, as the bidirectional flow of energy impacts the grid, utilities are still going to be held to those SAIDI and CAIDI standards. We have a lot of performance-based rate-based making at this point. So we need to be able to get our hands around how these uncontrolled assets are impacting the grid. So with that, we need to have more data to analyze to get the situational awareness to the grid operators. So in this case, we commonly refer to what we are utilizing in our PowerRunner on Pi solution as virtual Scada data. We're extending the Scada visibility down to the meters and distribution assets by pulling that data into the PowerRunner on Pi solution in near real time. And now we can run some exception analytics that essentially utilize AI and ML to find the signal through the noise, or Jim refers to it as the needle in the haystack, right? You can't have all this data across the system be useful unless it is essentially actionable information. So you need to be able to contextualize to support real-time operational decisions. And then from a prescriptive response, some of these actions just simply need to operate in real time. We need to feel or feed other systems that essentially operate on this data under rules and bandwidths and other metrics that actually perform analytics or feed other systems to do analytics. And then again, we're going back to the user configurability. The business requirements are constantly changing. If we are always waiting to revise a solution through an IT process that has to go through and do a new query and reconfigure an analytics platform, it's just going to bog down the SMEs that really need this information at their fingertips and their ability to essentially make these decisions. So it has to be configurable and reconfigurable at the SME level, not the IT level. So how do we do this? Let me just sort of take a little bit of dive into the PowerRunner technology and how we integrate with Pi. I mean, looking at today, we'll talk mostly about operational data in the use case that Jim will go through, and it's all pulled off of the Pi system at this time, except for a few contextual files. But essentially what we're able to do with PowerRunner is take all the chaos of this big data, all of these disparate systems, and pull them into a common platform, pull them into the PowerRunner energy platform, which allows us to create order from all of this disparate data by applying the proper data management and governance layers to this. And this creates essentially a single source of truth for the organization. From there, you can run analytics, you can run calculations, you can create forecast algorithms and actually create those configurable workflows. The key is that these solutions that we're building and deploying at our customers are actually inline production solutions. They're taking streaming data out of Pi and creating useful analytics that feed or support operational decision management. And again, the signal through the noise example is something that we'll go through today. So just to run through a few use cases that we are currently deploying at several utilities. One in particular, Ameren. We think this is really sort of a foundational grid analytics solution. It's a network model management. The concept is to essentially be able to constantly understand, or at least within a day, understand the relationships of all assets across the system. Now, obviously, from a DER integration standpoint, this is important. From an asset health perspective as well, if you want to understand loading on transformers, you need to understand all the meters that are correctly assigned to that transformer and likely to the feeders and substations. So we see this as foundational. We're doing this at Ameren right now. We're essentially taking a voltage profile off of every meter that is currently assigned to a transformer, creating a centroid profile for that transformer, comparing the two, finding where there are violations behind that transformer. In other words, a profile from a meter that doesn't match what the transformer profile looks like. And in that case, we're actually able to recommend. Again, this is that scenario where the AI is essentially automating a process and no one has to actually even intervene in this case. It's all automated. And we assign this to another transformer, a recommended transformer, and we compare again the voltage profiles across those two examples to validate that it is correct. Since the implementation of this, it's actually also been a layer that's interjected in Esri at Ameren, and they're able to visualize this as well on an overlay. So another use case that came out of, again, the engineers at Ameren who understood the data and understood what it is they needed to solve, came back to us with a shorted coil detection analysis. So we were able to monitor with the same data that we're pulling in for the previous use case, 15-minute voltage data, and we can identify various spikes or sags that may occur across a transformer. From there, we're able to actually integrate this into Esri as well. So I should go back for 1 second, got ahead of myself. This particular example here, we identified a rise of about 10 volts across this transformer for a sustained couple of days. This is before we fully implemented the solution, but this example on June 3rd, this transformer later failed on the 25th. And they've gone back and done some analysis using some historical data on their failures to see different anomalies that they could catch based on a failure that was known. So this is useful information that's feeding an algorithm now to continually monitor the system and try to find these anomalies as they occur. So again, as another integration into their Esri platform, this use case is currently being run about once a day. Ideally, in a perfect world, we would want to run it more frequently, which brings me to our next example, which is something that we're currently doing right now in a pilot with a relatively small utility. It's Burbank Water and Power. We kicked off this use case because it actually, Burbank actually has a very robust fiber network. So we have the ability to run these in near real time based on about a 5-minute voltage read across the system. So we're accelerating both of these previous examples of use cases to a near real-time function. So with that, I got one more slide. I'm looking at my time here, and I'm doing pretty good. So Jim, I'm going to hand it off to you in a minute here, but let me just sort of tee up the use case that we had with ComEd. And again, this is an example of the subject matter expert, Jim, coming to Pi, to OSI Soft and PowerRunner, because he had a use case in mind, and he understood how our technologies work together. So the challenge was that he's got thousands of DA devices spread across his system. They all have these multiple relationships that are their teaming relationships. And, you know, there was this one-to-many relationship that was difficult to maintain. And he'll go through and explain also difficult to analyze intraday. So the solution was to essentially pull this data out of Pi, extract it onto the PowerRunner platform, join those relationships across some of the other conditions. And the benefits have been to allow them to maintain these relationships in near real time. They reduced the amount of alarms that they were chasing by, I think it's greater than 70% now, Jim. And it's been an extremely valuable solution for their team. And I do want to point out, I mean, obviously from a collaborative standpoint, all three companies have been working towards building this out. So it's the first of its kind anywhere. So we're excited about its capabilities. So Jim, with that, I'm gonna hand it to you.
Okay, thanks, Dan. Thanks, Kevin, and thanks everyone for attending the webinar. As Dan mentioned, one of the things that we had a challenge with is we have DA devices that are out there, and they're in teams and they communicate with each other. And so as we go through some of these things, you come to the realization that things that you did in the past that were manually based, you kind of you got to change your way of doing things, and you need to move more towards an automated piece. Before I forget, I'd like to also thank my teammates, Tom Alford and Teresa Duran Carretero, because they were a large part of this effort as well. So going to the next slide, this is really ComEd. ComEd is essentially the upper fifth of Illinois. The upper fifth of Illinois, and it covers about 11,000 square miles. The biggest thing is somebody clicking? I'm not touching anything and it's jumping ahead. But so the biggest piece here that we need to show is somehow it's automatically going forward. I'm sorry. I swear I'm not even touching my mouse. So the biggest thing you want to look at is this 54,000 or 5,400 distribution circuits. So that's what we're looking at. So the agenda I have today is the main use case is what we call DA teaming. We also I want to have you take a look at the sequence auto learn, and then the future use cases that we have. There's some other things we'll go through on the agenda, but as we look at the DA team scheme, so if you look at this, this is kind of a representative isolation and restoration scheme that we have. So if you look at it, we have roughly 8 distribution automation reclosers. The red ones are actually sectionalizers. The green ones are ties where they'll bring in another power source. And they work in unison to isolate faults and then actually do the restoration. So let's take a look at an example. So if I place a fault here, what typically happens is these 2 devices, DA3 and 5, will open to clear the fault. In the old schemes, DA1 would have closed into the fault and then reopened because the fault was still there. But with the IT2 scheme that we're using from S&C, what happens in this scheme is DA3 and 5 will communicate with DA1 and tell it, don't close in, okay? So if the fault's here, this won't even close in. That does a lot of things. It takes the wear and tear off of this guy here for not closing into the fault. It also takes wear and tear off of the components on the actual feeder, okay? Now let's place a fault in a different location. Let's place it here, okay? If I place a fault here, what'll happen is this guy will open and this guy will tell DA4 not to close. So this is isolated. But this guy also opens, but right away with DA2 scheme, it says, hey, I went open, go ahead and close right away. So this guy will open and seconds later, this guy will close. So you actually minimize the time. So Dan talked about Katie and Safety. Katie is really duration and Sadie is the number, right? So what we want to do is try and reduce the number, the length of the outage, and also reduce the number of lights flickering, which is Sadie. It's the number of times this thing opens and closes. So that kind of gives you an idea. So now let's take the scenario of if I'm looking at a traditional Scada, I really only can look at a feeder level at a time because that's traditionally how they've worked. Now I've actually got 5 feeders up here, and as these, I'll say restoration or isolation and restoration schemes get more and more complex, your ability to monitor them so that they're ready to actuate is becoming more and more difficult to do these things manually. So if you take a look at this, it's okay. But now what happens is, what if I got 3,000 of these devices? Now how do I look at it? Am I going to scroll through all of this stuff if I'm going to pull alarms out and everything like that? So before we go on into here, what I'd like to talk about is ComEd has traditionally used Pi, like probably most companies. We store data. We use it in trending applications. We use Process Book. We use Pi Vision. We also do things like min values over the last day, over the last week. We do max values, average values. All of the things that I would say are more traditional based and are more yesterday based, right? They kind of, and they lend themselves to that. But what happens if you really want to start getting into this condition-based operation where you're going, I got a storm rolling through, or I have condition-based things where are these devices going to operate when they're really supposed to? So that's kind of what we're getting into. So it's more the 0 to 15 minute or 0 to 5 minute view and actionable I can go out and then I can do something based on the results I get. So that's kind of where we're moving towards, is the exception-based analytics, where you actually do something with it within the 5 to 10 minutes. So in the past, when we were looking at our team alarms, we would get a static report. Think of it as an Excel file, and it would have 150 to 250, and sometimes if we were lucky, we'd get more like 50. But if you have a bad weather event, you can have 300 to 400 of these. So it's tabular, and what it says is a particular device is an alarm. That's all it tells you. It's kind of like your car engine trouble light. All you know is you got problems. You don't know why. So it's point in time. So when we create this report, that report is static, and it might take us several hours. And by the time we get there, one of the downsides to this was the alarm might have already cleared. We don't know why it cleared, but it cleared, right? Or the other side of that is other alarms could be coming in and we don't even know it. We have to vet all the alarms because we need to make sure that our schemes, our restoration schemes, are available. And there's no team relation. So when you remember my diagram earlier, the teams like team 1, team 2, and those kind of things, on that report, it's basically just kind of sorted, and there's really no relationship. And we actually have 2 people that pretty much kind of, it's part of their daily activities, but they're spending time on these. So let's go into the next piece here. This gives you an idea of what the static report looked like, okay? It gave the region that it was in. It tells you the line or feeder number. Depending on the region, it could be a line, it could be a feeder. It just depends on the nomenclature. Gives you the point name. So we have a point name that just says team not ready. That's it. And it's an alarm. So you go through it, and we have to go line by line and validate each one of these. So this that I'm showing here on the left, this is how we do it. Well, let's kind of go where we really want to go to. And this is the exception-based smart alarms. So as Dan kind of mentioned earlier, the SMEs, we know the values that drive behind this and why this gets set for most of it, not every single thing. There's external alarms that cause this to go to alarm, and there's internal alarms. But we know those relationships. So we built something with PowerRunner, with OSI Soft, that took the data on the left and moved it to the right. And as Dan kind of mentioned, this was like a 3-month effort, okay? And this is our pilot, okay? So within 3 months, we were able to actually get data. And what I'm saying about that is we didn't even have the solution. We installed the solution on the pilot on a device we had, got it up and running, and this is where we're at to the alarm. So if you look at the left, everything is an alarm. But now as you look to the right, you notice something kind of big here. It's like, I only have, like in this case, 5 items that have to be reviewed further. Just 5. Before I might have had 100, 150. Now I only have 5. And you notice that there are ones that have been reviewed and it says complete no alarm. So these at one point in time went in and out of alarm, and now they're back in. These could be normal switching. These could be other activities going on. But these have been reviewed. The biggest one we want to take a look at that we also brought visibility to is, as we move forward and start deploying this across our entire environment of DA assets, we can start looking at out of telemetry, because everything we have is on the Itron network at this time. It's hard for us to really monitor the telemetry and how much of an impact that has, not only on just the teams, but the other pieces of that device as well. But this actually gives the team name. So this team might be, our feeders always start with an alpha carrier, an alpha numeric kind of thing. So it might be Charlie 339. So we might have a team that's on Charlie 339, and it might also have an adjacent feeder called like Alpha 4015, right? So these two could be on there. And this tells me when the alarm came in, and this tells me that I have to review it. It also told me it looked at these and I don't have to review those. So those are kind of nice features that we have there. So let's kind of move on. So as you look at it, if I select one of these, this is kind of the blown up view. If I select, say, this one here, this brings in a device that I have that's an EMC is a tie, which are normally open. So its off normal is closed. But in this case, the value for the status point says this device is open, so that's normal. It was not manually operated by our operations center. The restoration scheme is turned on, and you can't see this down below, but it's not in lockout tagout. So it should be in its normal state, but I'm getting an alarm here. So it's telling me that I have to go in and look at this. So I have to log into the device and see what the alarms are internally. And typically we'll go in and clear those alarms. But in this case, I don't have to do that. I mean, I'll have to do that, but in this case, I didn't have to look at everything. I only had to look at this one. So as we move on, let's take a look at a little bit here. These are the 5 status points, and this is where the SME knowledge comes into play, because our group, and I worked with Tom Alford and Teresa Duran-Carretero, we have these points. We know how these status points operate and their relationship back to this team alarm, okay? So it's either in the normal or it's alarmed. This gives you kind of the states that the values are that we look at. And then value 3 is, this is where it's out of telemetry. So you can see this is out of telemetry, which is something that we didn't have the mechanism to actually look at that, I'll say real time, or to really be able to effectively trend that or look at that, okay? So we have these 5 status points. We anchor on the team status point. So if we see this team status point go from normal to alarm, we know that it's no longer in its normal state, and we need to anchor on that. You can either call that anchor, and then what we did is we bookend back 5 minutes and said, okay, we know that 5 minutes ago is the most that we're going to look back for these other values to see what they are. And as Dan mentioned, there was some machine learning and there was some auto learning here, I'll call it. And basically it found 360 different combinations of all of these values and where they're at, okay? And you notice that you have this list over here, and this list, since this is a static report, but you can kind of see this slider bar right here. And that slider bar you can pull down and you can see all of the different status combinations. And the value of this is huge, because I didn't have to sit down and figure out, if I got a team and alarm, what are the other possible status values and things like that. It did it for me, okay? And we're still growing, but eventually it'll come to a static, kind of a static level. But these are my options. So kind of keep this table here in mind when we go to the next slide, okay? So the next slide is the configuration of those and what you want to do. So there's analytics behind each one of these buckets. So you can add these buckets, but essentially what happens is, notice how I have complete here or alarm reset. I look through, I grab the value, I grab the value sets and populate this. So it's a click and drag. So I kind of I'll hit this edit button. That table that you saw on the previous slide will pop up. I grab, slide it, and drop it on here, and I just add it, and now it's there. And I could do this for all of these, and you notice how I have the review complete, if closed, those kind of things, alarm reset, There's different things in here that I have, and you can add more buckets. But again, I'm not adding code changes to the solution from PowerRunner. I'm just putting my criteria on their analytics engine. So as we get through this, we kind of have to have a data flow so that everybody can talk about data flow. So PowerRunner sits over here in our enterprise. ComEd is a subsidiary of Exelon, and we call it the EEN, which is just our corporate network. So PowerRunner we're installing in our cloud-based solution, and it's going to be running on Azure, but it's an Exelon cloud, but it's off-prem. We have Pi Data, PiAF that's going and feeding it. We have this thing called GIS and DAC. And one of the things I want to kind of bring out is our GIS data here, which is called Commonwealth Edison GIS, is basically a flat file about the DA devices on our network. We have a lot of other files within this, our GIS database, but we really only want the DA devices. And there's a lot of metadata in there. It basically says this DA device name is on this feeder. It's this manufacturer. It's this kind of a restoration scheme. So it'll tell us if it's a legacy restoration scheme, or it'll tell us if it's the IT2 scheme. It also tells us is if this device is a mid-sectionalizer or is it a tie device. It'll tell us the associated feeder. There's a lot of data in there. It also tells us the GPS location. And the nicety about this file is we keep this file up to date. We keep the GIS system up to date. We can do an extract and it loads into PowerRunner. So this data goes into PowerRunner. So now me as I'll say the subject matter expert, I don't have to keep the number of devices we're adding, which is, let's say, I think roughly around 1,000 devices a year. I'm not spending my time adding those new devices into PowerRunner. PowerRunner consumes this file. Eventually we'll have a direct connection to the database, but right now we chose to do a file. And I keep what we monitor up to date. I say me, this file keeps it up to date. I don't have to do it. I also don't have to do maintenance of it either. So if we change a feeder number, we split feeders, we move devices around, we do things like that. There's a lot of other stuff. So this is a very dynamic solution. And again, what I want to bring out is we brought the use case to PowerRunner, but we didn't change the code of PowerRunner. All we did was create our rules around our use case. That's it. The DAC team file, it's another file somewhere else in a database. And basically that says this device is in this team. And again, I don't have to fill that into PowerRunner. All I do is point it to this file and it consumes a file and it automatically does it. So it basically takes the relationship of these two files and the Pi data and puts it into PowerRunner. And that's what you saw previously up to that. And it's a very powerful system. It's also a very, I'll say in this case, it's a very light footprint, but is very expandable. Okay, so if you only have a few use cases, you don't have to have 50 servers or anything like this. It can be a very small footprint, and it can grow over time with your use cases. So it's also very expandable. So with that, I want to go into our benefits real quick here. So one of the benefits was reduced review time for DA engineers. What we found is really only about 4% of the alarms we look at, we really have to work on. But that was 1 month. And typically it's about 10% we are actionable on. But to give you an idea, in the month of August of 2021, we had quite a bit. We had almost 5,000 DA IT2 schemes that were in alarm. And of that, only about 500 really needed to be looked at. And they all followed what we currently did in the pilot. it can be used for other applications besides teaming, obviously. I showed you, at the end of the day, kind of simplistic, but in a way really unique in the fact that what we're trying to do is use smart alarming where there's multiple status points that add up to be a alarm, and it gives us better insight into that. It's real time instead of point in time. So we're using the data 5 minutes ago, 15 minutes ago, and we're actionable on that. Let's go on to some future use case. One that's not on here that I'd like to point out is, you notice that the alarms were all red in the previous slide. In this scenario going forward, what we'd like to be able to do is color code them, because certain alarms are not actionable by our group and certain alarms are. So we would like to have the ones that are yellow more for our operations center, and then the ones that are red for our group. So we're even going to subcategorize our alarms. But we want to go into DA operations review. And if you remember my original feeder model that we had, to actually extend this to, hey, if I have a fault, if I can take the data from the DA devices and the circuit breaker, and I know what they did, maybe I can figure out if the DA operations scheme was correct, right? Because we also have to review all the operations to see if those are correct. Conductor slap is a different scenario, which is two devices. So let's say my first line recloser is right next to the circuit breaker. Let's say the recloser opens because of a downstream fault. There is so much energy that you can actually see conductors jump. And if there's too much, I'll say, slack in the conductors, or other issues where a conductor could be not actually connected, they can actually move together and cause an upstream fault, which then the circuit breaker trips. Going into DA health and being able to do a lot more dashboard integration and seeing things visually as opposed into a tabular form is key to us going forward with so many devices. Again, we want to get to the point of, instead of having the large number of haystacks, we need to present needles to people and say, look at this and work on this. So that's where we're trying to drive towards. So with that, thank you, everyone. Are there any questions?
Yeah, thanks, Jim. And thank you, Dan and Kevin. Okay, folks, at this time, we're going to take questions from the audience. Once again, please feel free to submit your questions through the Q&A option on the On24 digital event platform, and we'll answer your questions as they arrive. If we're not able to get to everyone's question today, we will certainly follow up with a response afterward. All right, so let's take a look at some of the questions we have here, gentlemen. All right, our first question. What can the system provide for the system planning engineer? Can you elaborate on load forecasting and capacity capabilities?
Do you want me to take that, Kevin?
Yeah, I was just going to say you can take it. I mean, of course, the Pi system would be a data source, but go ahead, Dan.
Well, in addition to the Pi system, PowerRunner, as I mentioned in our presentation, has an inherent forecasting capability built in. So there are several clients that use the PowerRunner and Pi systems to do very localized load forecasting, not just in near real time, but obviously for system planning perspectives. And because we are working on meter data level forecast, we're able to get very localized and incorporate the impacts that DER are having on specific circuits and how their future growth might impact that circuit. So the combined solution actually can address what we see as a more frequent system planning and more localized system planning requirements for utilities.
Excellent. Thanks, Dan. All right, our next question. If I'm already a user of the Pi system, what is the process of using condition-based monitoring? Is it something as simple as a service order to set up?
I'll take that one. This is Kevin Walsh. Depending on what contract you have with OSI Soft, there's a component in EA. If you're an EA client of OSI Soft, we can engage in workshops, and that would cover, kind of reaching out to the departments and the subject matter experts on the customer side. And also it would gather where and how to get the data, where and how to configure your AF and your AF analytics, and event frames and notifications. So it's not a work order per se. And if you're a component, there's other ways. But if you're an EA client, just engage with your customer service manager on workshops around that. We can jumpstart it with you.
Gentlemen, can you elaborate on the interfaces that you support?
Dan, I'll start with the Pi system since we typically ingest most of the data. We have, from the ADMS side, most major vendors, either they supply it or we have it. That's from the Scada point of view. But if you're also collecting, and some utilities are starting to get secondary pathways for this data out of the substations into corporations, we support the 61850, DNP, Modbus, the C37118 protocol for PMU data. But we also have the litany of, the UFL connector, which is a universal file loader. We have XML. We have web services to move the data around. So we have we have over 450 interfaces for the Pi system, but those are the majority of the major ones within the utility framework, utilities customer set. Dan?
Right. Well, and that's great that Pi is actually grabbing all that data already, and we leverage a lot of those, leverage the power of Pi's vast number of interfaces, and have built a direct PowerRunner to Pi gateway, in which we are able to extract all the data from those sensors and systems that Kevin was just referring to, those interfaces that touch those systems. And in addition, we have a very robust ETL layer that can tie into all the commercial systems as well as external systems. So CIS and GIS, which may or may not be in Pi already, but that data can come into PowerRunner. And we also integrate with external systems. Many of the markets, when I say markets, ISOs across the country, we are integrated with through our clients, pulling market data in or pushing schedules out.
Right.
So we've got a robust layer as well.
Yeah, and another note of that, thanks for reminding me, Dan, is that we do have our integrators, which are with, Esri, the GIS solution. We got BI, business tool integration. So it's a very robust system to get data in and out of.
Gentlemen, how do you figure out the specific parameters for each asset here?
Again, Dan, I'll start. I don't know if you have any comments.
I was going to say this might be a good question for Jim.
Yeah, let's get Jim to talk.
Yeah, I'll take this one. Thanks, guys. Hey, so ultimately, one of the things that is it moves it into the subject matter expert, and we know how our devices work. We have a lot of devices, but a lot of them are the same kind. So we have an understanding of the relationship with the data to itself. There's data that we don't, but we knew at the time going in that these four status points made this other point up. So we actually, I'll call it basically on the job condition learning. We've come up with these relationships over time. So all we had to do was present that use case to OSI Soft and Pi, and we were able to, like Dan said, and like I said earlier, we came up with something fairly quickly. We leveraged the ETL tool. So the nicety here is we didn't have to get PowerRunner to update the code, which is huge for us because now it's still just a vendor supported solution with no customization. I'll say at the code level, all the customization is allowed for you at the user interface level, which is huge because now I can have our subject matter experts, myself or whatever, can go in and do things to actually make the changes and not wait for, I'll say, a third party to do that for us.
Jim, Dan, can you elaborate on how you integrate with the Pi system platform for real-time visualization? We have a couple engineers who have asked that question.
Well, as you can tell from my title, I'm not the engineer, but we do have a AF-SDK platform, or I should say integration platform, that we've built specifically to tie into the Pi system. I couldn't really explain to you more technically than that our engineers have built this. It scales on a parallel basis. So we're able to extract data over into PowerRunner relatively quickly, more quickly than previous attempts at using other integration tools with Pi.
And I've got a couple comments there too, Dan, from the Pi platform perspective. We do have our web API, we do have our AF SDKs, but we have our BI integrator, which actually can schedule if you're streaming data. We can stream or schedule data to be sent out of the system in a formatted way. So there are a couple techniques and a variety of capabilities to get the data out of Pi to put it in any platform, visualization platform. But, we do have our native Pi Vision 2021's coming out at the end of this month, which has some robust capabilities that are heading out to the market now.
Great. Thanks, Kevin. Thank you, Dan. All right, let's just see if we have any more questions here. All right. Well, if there are no further questions, I'd like to thank everyone for attending today's webinar. If you do happen to have additional questions following our live event today, please feel free to submit them through one of the follow-up emails sent out after the conclusion of our event. Once again, thank you for attending. And Kevin, Dan, Jim, thank you for presenting and joining us today.
Yes. Thank you.
Thank you.
Thank you.
All right. Take care, everyone.